Greetings to all participants of the conference. Let's present to you the work on the topic analyzing by-product interaction as an industry resource of cycle economy in Ukraine and the world. The international teams of our authors Myroslava, Bublyk, Vadim, Shandurskyi, Machita, Piotr, Grudowski, and Oleksandr Pavlyuk in United scientists from Ukraine and Poland, namely from Lviv Polytechnic National University and Gdansk University of Technology. These problems was investigated of the first time since 2007 for making managerial discussion in this sequel economica. This problem was highlighted in several professional articles and monographs, collectives at my monograph for the doctor science dissertation and discussed at international conference. We have already considered the mechanism of the formation of technosolitons in industrial symbiosis. The problems of byproduct interaction in Ukraine and the world received further developed in the presented work, as a result of which are briefly presented here. There are three main types of nuclear waste: high-level, transuranic, and low-level waste, that each type must be disposed of accounting of its risk to the human health and the environment. Most people refer to nuclear waste as the fuel used in reactor 1s. Most of the radioactive association with the nuclear power remains contained in the fuel in which it was produced. This is why used fuel is classified as high-level radioactive waste. All the nuclear waste a power plant generates in its entry lifetime is stored on site as drying kegs. The dataset contains information about the extraction of uranium-contained materials in Ukraine and other countries. Datasets is namely quantity produced nuclear waste from 2018 to 2021 in Ukraine. The data set contains information about the available nuclear waste of years from 2018 to 2021. State enterprise Eastern Mining and Processing Bank is a state-owned enterprise, one of the 28 uranium mining centers in the world, among which it is the top 10 and it is also the largest in Europe. This is one histogram depicted dependence on nuclear fuel and waste products in 2018-2021 in Ukraine. We used a histogram to represent tabular data on the extraction of uranium-containing materials at the Eastern Mining Processing Plant, and with the aim of the representation distribution of the numerical data. A diagram consists of a rectangle without the gaps between them. This is one tree map depicted dependence on nuclear fuel and waste production in various countries of Europe. Analyzing this graph, we can observe significant number accumulation of waste in such countries as Romania, Germany, and Great Britain. On given graphics display density distribution production nuclear fuel and waste during 2018-2021 in the figure shows as diagrams density of factor criteria and alternatives. In our investigation, we got acquainted with the task in detail with the sphere of influence of waste in Ukraine and other countries in Europe. We did a detailed analysis of the chosen dataset and demonstrate results in practical part. We also prepare a theoretical part according to this topic, and having spent the region to analyze conducted that is Romania most number format household and enterprises. Three problems of the using nuclear waste can be identified. The need of the prevent environmental damage Second, looking for the way to refuse resource, and third is conversion of nuclear waste into a resource. The nuclear fuel recycling process is straightforward. It involves converting spent plutonium and uranium into a mixed oxide that can be refused in nuclear power plant to produce more electricity. The nuclear fuel recycling process is straightforward and involves converting spent plutonium in this mixed oxide. The nuclear materials that cannot be recycled is embedded in glass rock. In post its used fuel in deep geological repository as it feed via worsted waste that not valuable resources for clean energy production is folly. The problem is lifting the ban of the nuclear fuel recycling, which would cut the amount of the waste requiring disposal by one that half. One facility would be sufficiently to store a nuclear plant waste, reducing disposal costs by billions of dollars. It is important to build a nuclear recycling facilities. That facility will produce mixed oxide fuel for generation electric power, not from power plant waste, but from supplies plutonium now in weapon stackables. By lifting the ban of the spent fuel recycling, we could use a valuable resource, provide an answer to the nuclear waste problem, open the way of the new generation of nuclear plants to meet growing electricity needs, and put Ukraine in leadership position in climate change action. The problem of lifting is this nuclear, which would cut waste requiring disposal by more than half, and now we can use it by the production of electricity. So at the end, available and well-known scientists' development and leaders' resource were studied and analyzed. The advantages and disadvantages of various industries of nuclear waste in Ukraine were highlighted. The stable connection between the factor and criteria is assessed by the production interaction in industry resource was established. The expediency of choosing the R Studio and Power BI desktop and language program in R is sustained. With the help of the histogram, tree map, and density diagram, VMont nuclear production was provided. Thank you for your attention.